Francis.
I'm Eugene.
Hi, I'm Earl.
I'm Hillary.
And I'm Sandy.
And this is Marian, and we are the Group 1.
And welcome to the upside-down world of mathematics, the Euclidean geometry.
It is called as such in honor of its founder, a Greek mathematician, Euclid. Architecture, engineering, interior designs, animations, and computer graphics, and even biology and medicine are some of the disciplines that have been prospered throughout the ages, contributing to our modern technological advancement.
But lurking just beneath the surface of our modern-day world lies the contributions of the Euclidean geometry, which catapulted the aforementioned fields towards the far progress they have achieved today. Now, brace yourself as you are about to learn the fundamentals of geometry as you journey towards the upside down.
Good luck, survive, and don't get caught by a vector.
We will be tackling the table of contents. First, the basic concepts of Euclidean geometry and its two types. Second, the basic geometric terms such as point, line, line segment, ray, and plane. And lastly, we will be tackling analysis and recognition with geometric shapes along with its types.
Basic geometric terms includes fundamental elements such as points, lines, planes, angles, and line segments. These fundamental elements were formed for basis in understanding complex geometric shapes and concepts.
A straight line can be drawn between any 2 points. It is the simplest geometric connection. Lines can be extended endlessly in both directions, and they never end. Circle can be drawn from any center with any radius. All right angles are equal at each one exactly 90 degrees. If interior angles add up to less than 180 degrees, the lines will meet on that side.
Vecna is the origin of the upside down's evil and intelligence. And just as a point undermines all of geometry, Vecna is the seed of chaos. Without Vecna, there will be no evil in the upside down. Without a point, geometry will not exist. The point is Vecna geometry. A point is defined as that which has no part. In simpler terms, it has no length, width, area, or volume. It's completely dimensionless. Its only property is location. We can use points to mark exact positions in a space. Here are some key characteristics of a point. It is dimensionless, it has no size or shape, it marks a specific location on a plane or in a space. It is the building block of geometry used to create lines, angles, and shapes. According to Euclid's postulate, two distinct points determine exactly one line between them.
Just like the line, the mind flayer is the ultimate representation of the infinite control, a hive mind stretching from the parallel world of the upside down into the real world. Just imagine how far it can go if it has the ability to cross dimensions.
Line. A line is a straight path that extends infinitely in both directions. This means it has no end and no beginning. It just keeps going forever. A line has length, but it does not have any width or thickness. A line has length, but no width. 2 points are enough to define a unique line. That means if you have 2 points, you can draw exactly one line passing through them. A line can be named using a lowercase letter, such as line G in the diagram. It can also be named using 2 points on the line. For example, if the points on the line are P and Q, we can name the lines as line PQ or line QP.
Apart from being a mind flayer, let us also think of lines as those tall entities called demogorgons. Now, if lines are demogorgons, we can assume that line segments are demodels, adolescent and the shorter stage of demogorgons.
A line segment is just a part of a line. It's 2 points in the line between them. Unlike the line, it is not infinite, but rather bounded, short, and direct. Line segment also has measure, its length, and it can be named by its endpoints. For example, we have a line segment between points A and B. To name it, we shall put the two capital letters together and add the symbol of the line segment above, which is a horizontal line.
Next up, we have the flayed. The flayed are people or animals mentally overtaken by the mind flayer. Now listen, this phenomenon spreads like a disease. Again, it spreads or extends. A 1D geometric shape that we can relate to the flayed is the ray.
The ray, also a part of the line, has one fixed point and another point that has no end. It starts at a point and extends infinitely in one direction. Now don't be fooled by the following terminology, because the end point of a ray is actually its starting point. At least 2 points are needed to define a ray. Its end point is its origin, and its second point guides the direction the ray goes. It can contain or pass through infinitely many points as well, since it continues forever in one direction.
In naming rays, it is important to follow the following guidelines.
Number 1. Rays can only be labeled with 2 letters even if it contains numerous points. These 2 letters should be its endpoint and the second point which leads the ray's direction. The rest of the points beyond the second point doesn't necessarily have to be written like this, or else the name would be invalid. Number 2. The ray symbol, which is an arrow on top of the letters, should always point towards the right, never to the left, never up, and never down. The direction of the ray itself is determined by the order of the letters or points, which leads us to number 3, where it says the letter of the endpoint should always come first. Always, because that's where the ray begins.
Now that we have discussed all the creatures in the upside down, it is time to discuss the upside down itself, introducing the plane.
You have been introduced to the basic one-dimensional shapes of the Euclidean geometry. Now, what do you think will happen if we create a string of 1D shapes such as lines? Right, we create a 2-dimensional space, a plane. If we can also gather a string of planes, we can also create a 3-dimensional space. But first, let us get to know what planes really are. A plane, on the other hand, has 0 thickness and perfectly flat. It may be impossible in reality, but it is very useful in theorizing and modeling things. The conclusions we get from discussing planes concretely is useful in real-life applications, such as in the field of architecture and engineering.
Think of a plane as a grid of lines. The lines on the plane can be perpendicular, intersecting, parallel, and concurrent. Parallel lines are 2 or more lines in a plane that never intersects. The distance between these lines are also constantly the same. In this diagram, we have 2 lines, line L and line M. Line L and line M are parallel lines because they do not connect and they have the perfect constant distance between them. Now let's add one more line, line O. The diagram now shows an example of intersecting lines.
Intersecting lines contains 2 or more lines that cross at one point in the plane. As you can see, line O passes through lines L and M, effectively creating a graph of intersecting lines.
Perpendicular lines, on the other hand, are 2 or more lines that intersect at 90 degrees angle, like this, also noted by the following symbol. And lastly, concurrent lines are 3 or more lines that are passing through the same point. Think of perpendicular lines with more lines intersecting at its central point.
And that's it. You finally reached the end of the journey of the upside down. Now, why don't we wrap things up? Right, Francis?
Oh, hi there, Earl. It really does say here that this is the end.
We hope you enjoy your journey to the upside down of mathematics. If you have any question about this mysterious corner of math, you can be referred to the handout that we provided,
where you can not only review about the topic, but also revisit how we use the monsters from the Netflix show as metaphors for introductory concepts in geometry.
Once again, this is Group 3,
Your reporter for the basic concept of Euclidean geometry.